Welcome to this deep dive into analytical techniques for managers. In today's fast-paced business world, data-driven decision-making is the key to staying ahead. Whether you're managing projects, teams, or business strategies, the right analytical techniques can help you make informed, effective decisions. In this video, we'll cover essential techniques every manager should know, including SWOT analysis, decision trees, regression analysis, and more. By the end, you'll have a toolkit of methods to tackle challenges with confidence. Let's get started. Section 1. Why analytical techniques matter. Managing without data is like driving blindfolded. Successful leaders don't rely on gut feelings alone, they use data and analysis to guide their decisions. From improving efficiency to predicting market trends, analytical tools help managers reduce risks and optimize results. Now, let's break down some of the most powerful analytical techniques you can use today. Section 2. SWOT analysis. SWOT analysis is a strategic planning tool that helps organizations and individuals evaluate their current position in the market or within a particular project. The acronym SWOT stands for Strengths, Weaknesses, Opportunities, and Threats. A SWOT analysis is a framework to help assess and understand the internal and external forces that may create opportunities or risks for an organization. Strengths may be any number of areas or characteristics where a company excels and has a competitive advantage over its peers. Advantages may be more qualitative in nature and therefore difficult to measure, or they may be more quantitative. Weaknesses are areas or characteristics where a business is at a competitive disadvantage relative to its peers. Like strengths, these can also be more qualitative or quantitative. Examples include inexperienced management, high employee turnover, low margins, and high use of debt as a funding source. The opportunities section should highlight external factors that represent potential growth or improvement areas for a business. Consider opportunities like a growing total addressable market (TAM), technological advancements that might help improve efficiency, or changes in social norms that are creating new markets or new subsegments of existing markets. Threats are external forces that represent risks to a business and its ability to operate. The categories tend to be similar to the opportunities section, but directionally opposite. Consider examples like an industry in decline, which is the same as a decreasing TAM, technological innovation that could disrupt the existing business and its operations, or evolving social norms that make existing product offerings less attractive to a growing number of consumers. Section 3. Decision trees. A decision tree is a support tool with a tree-like structure that models probable outcomes, cost of resources, utilities, and possible consequences. Decision trees provide a way to present algorithms with conditional control statements. They include branches that represent decision-making steps that can lead to a favorable result. Let's see why we should make a decision tree. Decision trees are flexible. They effectively communicate complex processes. Decision trees gives attention to probability and data, not emotion and bias. They clarify choices, risks, objectives, and gains. The flowchart structure includes internal nodes that represent tests or attributes at each stage. Every branch stands for an outcome for the attributes, while the path from the leaf to the root represents rules for classification. Decision trees are one of the best forms of learning algorithms based on various learning methods. They boost predictive models with accuracy, ease in interpretation, and stability. The tools are also effective in fitting nonlinear relationships since they can solve data fitting challenges, such as regression and classifications. Decision tree symbols. The first symbol is a decision node, normally represented by squares to display decision to be made. The second symbol is a chance node, usually in a circle to show the uncertain outcomes with possibilities. The third symbol is an end node, often shown by triangles to show the final result of a decision path. The fourth symbol is an alternative branch, which reflects a possible result or action, And the fifth symbol is a rejected alternative, which displays an option that wasn't selected. Section 4. Regression Analysis. Regression analysis is a statistical method used to identify relationships between variables. It can be utilized to assess the strength of the relationship between variables and for modeling the future relationship between them. Regression analysis includes several variations, such as linear, multiple linear, and nonlinear. The most common models are simple linear and multiple linear. Nonlinear regression analysis is commonly used for more complicated data sets in which the dependent and independent variables show a nonlinear relationship. Regression analysis offers numerous applications in various disciplines, including finance. Regression analysis, linear model assumptions. Linear regression analysis is based on 6 fundamental assumptions. 1. The dependent and independent variables show a linear relationship between the slope and the intercept. 2. The independent variable is not random. 3. The value of the residual error is 0. 4. The value of the residual error is constant across all observations. 5. The value of the residual error is not correlated across all observations. 6. The residual error values follow the normal distribution. Regression analysis, simple linear regression. Simple linear regression is a model that assesses the relationship between a dependent variable and an independent variable. The simple linear model is expressed using the following equation: y equals a plus bx plus a, where y, dependent variable, x, independent explanatory variable, a, intercept, b, slope, a, residual error. Check out the following video to learn more about simple linear regression.
The aim of simple linear regression is to model a straight line relationship between two variables, x and y. The modeled relationship is called the line of best fit. And that's the model's way of describing the relationship between these two variables, which can be used to predict new values of y, our dependent variable. If our independent variable describes the target variable well enough, then all the remaining scatter in the data around the line of best fit should just be down to random variation that cannot be reasonably explained. In this example, we've collected data on the building area of various houses and their corresponding prices. We can use the building area, shown on the x-axis, as our independent variable to predict the house price on the y-axis. So in this example, house price is our target variable. Each blue point on the right represents a single house for which we know both the area and the corresponding price. By finding the line of best fit shown here in orange, we can then predict the house price for any building area, even if we haven't observed that specific value before. It also allows us to use the entire dataset to find the best overall trend between house price and building area. Our line of best fit follows the trend we would expect, where a bigger house is more expensive. But the house price is almost certainly influenced by more than just the area of the house. For example, the area, such as urban or rural, will almost certainly have an impact, or even the condition of the house. Fortunately, we could use multiple linear regression to incorporate more independent variables into our model at the same time. We'll return to this idea in the next chapter, but for now, we'll stick to simple linear regression with one independent variable.
Section 5. Cost-benefit analysis. Cost-benefit analysis is a process performed by individuals, governments, and businesses when considering a course of action or proposed project. It serves as a framework for evaluating the desirability of an action by comparing total benefits against total costs. If the expected net benefits outweigh the expected costs, then it makes sense to undertake the action. If the opposite is true, costs outweigh the benefits, then the action would not be undertaken. Effectively, CBA assumes that the benefits of an action will always have an associated cost and that these costs can be factored into the analysis. It's only by understanding all of the direct and indirect benefits and all of the direct and indirect costs that a planned course of action should or should not be taken. From a finance perspective, One subtype of cost-benefit analysis is net present value. Key highlights. Cost-benefit analysis is a process performed by individuals, politicians, and businesses when considering a course of action. For a company to create economic value for its stakeholders, it must invest in beneficial projects. After a thorough consideration of all of the benefits and costs, the company can then make the determination whether the project will add value. If cost-benefit analyses are not performed, then it is possible the company may be investing in value-destructive projects. A major limitation of cost-benefit analyses is that it may not be possible to adequately understand all potential expected benefits and costs. Section 6. Root cause analysis. Root cause analysis is the process of discovering the root causes of problems in order to identify appropriate solutions. Root cause analysis assumes that it is much more effective to systematically prevent and solve for underlying issues rather than just treating ad hoc symptoms and putting out fires. Root cause analysis can be performed with a collection of principles, techniques, and methodologies that can all be leveraged to identify the root causes of an event or trend. Looking beyond superficial cause and effect, root cause analysis can show where processes or systems failed or caused an issue in the first place. Tips for performing effective root cause analysis. Ask questions to clarify information and bring us closer to answers. The more we can drill down and interrogate every potential cause, the more likely we are to find a root cause. Once we believe we have identified the root cause of the problem, we can ask even more questions. Why are we certain this is the root cause instead of that? Work with a team and get fresh eyes. Whether it's just a partner or a whole team of colleagues, any extra eyes will help us figure out solutions faster and also serve as a check against bias. Getting input from others will also offer additional points of view, helping us to challenge our assumptions. Plan for future root cause analysis. As we perform a root cause analysis, it's important to be aware of the process itself. Take notes. Ask questions about the analysis process itself. Find out if a certain technique or method works best for your specific business needs and environments. Remember to perform root cause analysis for successes too. Root cause analysis is a great tool for figuring out where something went wrong. We typically use RC as a way to diagnose problems, but it can be equally as effective to find the root cause of a success. If we find the cause of a success or overachievement or early deadline, it's rarely a bad idea to find out the root cause of why things are going well. This kind of analysis can help prioritize and preemptively protect key factors, and we might be able to translate success in one area of business to success in another area.